I'm currently working as Director of Data Science and Machine Learning Engineering, which is part of Advanced Analytics Group at Bain and Company. For those of you who are not aware or familiar with Bain and Company, it's a management consulting firm, and it has different functions like engineering, analytics, data science, as well in-house. I have published a few books on technical subjects. My core expertise is into PySpark and large-scale machine learning, and I like to read in my spare time. All right, so what are we going to cover today? Today, we'll start with some of the basics and fundamentals to sort of lay the ground, to make you understand what is Docker, what are the specific components and internals of using Docker. Then we'll try to see what's the comparison between a virtual machine versus a Docker container, right? The third part would be to go and look into different components of Docker ecosystem. What are some of the core components which are interconnected, as well as which are more relevant for your work or purpose. In the hands-on part, we will see some of the basic Docker commands, and at the end, we will see how we can build a machine learning application, including a sort of simpler UI, and sort of package everything in a Docker container and run it on the local host. Okay, and as Manish mentioned, if there are any follow-up questions, happy to answer at the end of the session. All right, so just to draw an analogy, when things used to get transported from one place to another, right? For example, vehicles or oil or petroleum, right? Or food grains. Before, from one country to another or within one country, there was no standardized process, so as to say, right? So it was not very optimized way of transporting or food grains from one place to another. Till there was this containers which came into picture, right? What containers did, it sort of standardized the way things are transported from one place to another, because now these containers had specific dimensions which were followed across the globe, right? So be it cars that needs to be transported, or be it petroleum or oil or food grains, anything within the transport bracket, they would sort of optimize the way in which these could be packaged and put in a container, and that could be transported from one place to another. Couple of advantages. One was, now you could use the space within the container in a more optimized way. And second was, since the dimensions were standard, so for a small container or a big container, the road transport, for example, the trucks which take these containers would follow the dimensions or have would have the structure that it can easily take the containers from one place to another. Similarly, the trains, right, or the rails had similar dimensions that could take containers from one place to another, and ships which take these containers or transport these from one place to another, as well as the cranes which move these containers or loads or unloads from the ships, right? So what containers enabled was the easy transport from one location to another in an optimized manner, right? Now, the supplier doesn't need to worry about whether am I sort of sending this material and how this would be handled at the receiving end, right? Or how the receiver would it be broken? Would there would be repercussions because there are damaged goods because of the transport? Those complexities were taken away because there was a standardized process in picture, and that's what containers enable, right? So similarly, what Dockers enable is, and first of all, if we can take a step back before seeing what exactly is Docker, just try to see if we were to install any application on our system, be it Mac or Windows, what do we do? What is the traditional process that we follow, right? We download installer for installing that particular package or application. You have installer files, right? So we try to run the installer, follow the instructions, we choose the location, and sometimes we run into error. The reason, the operating system, maybe some of the dependencies or configuration are not, there are certain errors or certain versions that are mismatched, right? So you run into error, and that what you try to troubleshoot the issue. In terms of troubleshooting, you try to change either the location, you try to change some of the versions of the files that are already on the system for compatibility, and you retry the installer again. Okay, what happens is sometimes you again run into error because there are certain other dependencies that the application needs for that system to have in order to get installed. And for some of the application, we directly successfully install those, but few of the cases, there are certain OS related dependencies that are in conflict of installing the application. So this is one of the common scenarios where Docker can help. Second is, imagine you are a developer, right? You are developing an application and it runs perfectly fine on your system. Maybe you have certain operating system, right? Maybe Windows. And what happens is you give it for testing to another team member who's maybe on a different operating system or using a Linux machine or a Mac machine. Now, he or she tries to run that piece of program and they run into error. What happens is the issues crop up from the difference in the underlying operating system or the file structure, or there could be a number of reasons, but the program doesn't run. But if you run it on your machine as a developer, it works perfectly fine. So that's a common scenario that people run into because of the difference in the underlying operating system, right? So if I were to put all the challenges that we face without using Docker, is like, if you were to manage running applications, dependencies, and technologies stack across the platform, it's a challenge because some of these could be running on Linux, some of these could be running on Windows. So it's difficult to have a consistency across all the applications. Second is, you want to keep the application operational and stable, right? So moment you are running it on Windows, and if there's a change in the running platform, let's say you are migrating, you want to have that consistency that it runs on another platform also, right? And as soon as if you change the environment for an application, there are certain bugs that come in because of if you have released a new version, because of there's a compatibility issue or configuration related issues, right? And you also want to ensure that if you push any new release or a version of the running application, you don't want it to impact the runtime or sort of the current execution that is going on. So these are some of the challenges that are faced by the developers if they are working between different platforms. So what does Docker enable, or where it is useful, right? Let's say you're building a program in Java. So you would typically have a jar file that you want to execute. If you're building a Node.js, let's say you would have a zip folder of all the files that you can then run it on a host or a server. If you're building a Python program, you would have set of executables that you can run on host. But it would have certain dependencies to be run on certain platforms. What Docker does is it packages all the dependencies, configurations, binaries, or other files that are required to run an application on a given platform. Okay, when I say on a given platform, it works, like I said, as an example of container, right? It can be taken by truck, it can be taken by train, it can be taken by ship. So irrespective of what is the application do, if you're packaging all the dependencies and binaries using Docker, Docker would ensure that it runs on local system as it would run on any cloud system or any remote server. Okay, so as long as you are enabling your application or packaging your application using Docker, it would ensure that your file runs perfectly fine on the platform. I'll give you an example. Let's say you want to install Redis, right? Redis is a database. So what I need to do in order to install Redis. So I'll need to do wget, download the Redis tar file from the location. Then I have to unzip it. Then I have to go into that directory and do a makefile, right? These are the steps that I need to follow. And possible that I might get run into some errors like I did, right? So if I run wget a particular tar file from the location, I get wget not found, right? So I have to install the required files first. So fix this first. Then the file gets downloaded finally. Then I have to unzip it, right? So I unzip it. Then there are other errors that I run into. So you can see the overheads are to an extent higher if you were to install any application on local system. But using Docker, it just sort of takes away all the complexities from installing the files or building the application, because single line command like docker run redis would ensure that you have Redis available for access and use it. Okay. In short, Docker allows to sort of package uh, all it, and you can call it as a sort of sandbox environment, because it would have all the libraries, configuration files, and other dependencies, and you can ship it like on any system, any host, any sort of, you can deploy it on cloud, and that's what Docker enables, right? So if it runs fine on your local machine, it would run fine in your test environment as well, in a staging environment as well as on the production environment. You don't need to change too many variables when you're using Docker. Okay. So this was what Docker is overall, why it is used, what it offers. Okay. Now we can go into traditional comparison of virtual machines and Docker. Okay. Now, some of you might have used virtual machines already. Virtual machines are again used for providing isolated environments on a host machine, but it has certain overheads, right? So you can think of virtual machine as a computer sitting within a computer, right? So if I have a Windows machine whose hard disk, let's say hardware is 1 TB, I can have, let's say, 3 virtual machines, with one with a Linux OS, one with the Windows OS, one with the Mac OS sort of thing, right? Virtual machine enables for you to use different operating system itself within the machine, whereas Docker doesn't need you to have a separate operating system than the host system. Okay, so if it's a Windows machine, you don't need to separately install Linux or Mac OS. What it does, it virtualizes only on the application layer, right? So you still sit on the host operating system, but you don't need that much of complexity or resources in order to install Docker or use Docker. Okay, so we'll just go a little deeper into it to understand it, what exactly virtualization means. So if you have any typical application running on a server, you have the core piece, which is your hardware, which is your RAM and CPU. All those are your hardware and sort of enables for you to run the applications, right? Then you have a host operating system, right? It could be Windows, it could be Mac or Linux, but this is how it generally looks like, because you can have multiple applications running on a system. For example, I'm running Zoom right now, so that could be one application. I'm using Chrome, right? That could be another application. Now this application, let's say Zoom, would have its own sort of set of libraries, binary files or other configuration files that are required in order to run the application, right? Without these files or the core input to the application, you won't be able to run the application. Similarly, for other applications, you would have some system files. So that's what you need to have in order to run the application. And kernel is basically the bridge between running the application and communicating with the hardware. It's what your host system would enable. Now, what happens in VMs, you have, let's say, a window machine, and you have a kernel or host system. You have a layer of hypervisor. Okay, what this hypervisor does, it enables for you to have different operating systems installed on the same machine. So this could be Windows, this could be Mac, or a Linux based system. But now you can run these applications independently, without sort of in an isolated environment, without being affected by another application being run. What traditionally happens if you're running only a couple of applications on a big server, you are underutilizing the resources, right? You're not all of the resources are used. Plus, there's a long boot up time because you are using heavy hardware. Okay, that's where VMs come in picture, right? So you can run multiple applications as in an isolated environment. But what happens is VM dedicates a specific set of hardware, software resources for each of the VM. Okay, so now this app which is running on VM1 would have a dedicated set of hardware resources and other system files. This would have a dedicated, and this would, so hence what happens is you end up dividing the or attributing the hardware resources to all these VMs, and as a result it's slow to boot up because you are virtually creating a new system within the system. Okay, so that's how VMs work. But in case of Docker, you can clearly see a distinction, right? It has something known as Docker engine. What it does, it virtualizes it on the OS level. So it doesn't need to sort of have different OSs for each of the application or Docker. So assume this is container 1, this is container 2, this is container 3, and we'll get into what are containers. But this container is running one app and it has all the required binaries and libraries. But for any hardware related resources, it would communicate with the Docker engine and use that much of hardware without need to have a dedicated sort of system. Depending on what type of application you're running, you can use the different container sizes. So that's the difference. Like for VM, you are sort of virtualizing based on the hardware, whereas in Docker, you try to virtualize on the layer of application itself. So I'll give you an example, and I hope this would make it clear. Imagine bungalows, right? It's built on a single piece of land, right? It's not shared with anyone. They are expensive. They are isolated, right? They have their own parking. They have their own security. They have their own supply of water, electricity, and everything. They do not share resources. Okay, and it's for one family only. So you can call it as a bare metal or a single server, which is very heavy. And what ends up happening is you don't use all of it. You don't use the rest of the parts of your bungalow, and some of it is idle. Similarly, in a bare metal kind of scenario or setup, you don't run multiple applications on a single server. That's what this is the bungalows example. Coming to row houses, right? Row houses are commonly a gated community, right? So although there are isolated or individual things, but there are few common shared resources as well. For example, you share park, you share the clubhouse, you share security, right? So those are the things that row houses families would share, but in each row house there would be one family living. So comparatively little cheaper from bungalows, and this isolation is limited. It's not completely exclusive. So you can think of it as a virtual machine because you are sharing your hardware, but each application is running into a different VM. Finally, the apartments, right? Now apartments, all the apartments are built on the single piece of land now. So if there are 100 apartments, you have same piece of land. So that means land itself is shared across the 100 flats. Then you have common gas pipeline, let's say same gas connections, you have security, you have clubhouse, all those are more shared. Now you have shared floor also. On one floor, let's say there are 2 apartments or 4 apartments, you're sharing the floor also, you're sharing the lobby also. So now you can see how you can aggregate or have more number of families living on the same piece of land where there was only one bungalow, or let's say 3 row houses where only 3 families were living, but now you have 100 families living, and that's how the difference comes in, right? So it's more cheaper. It's for exception of some of the apartments which are costlier than bungalows and row houses, but you get the idea, right? You have maximum resource sharing, and that's what Docker container offer. Okay, so you share most of the resources between the applications with while maintaining the isolated environment, right? So the two applications would still run differently, but they would share most of the resources. All right, now coming on to the Docker ecosystem. There are 4 main components when it comes to Docker ecosystem. One is Docker client, which is your CLI, through which you use Docker. Next is Docker server. Docker server is what which does all the heavy lifting, all the running of containers and everything. So you can think it of as kernel for Docker. Okay. Then you have Docker images, which are essentially the blueprints, and we'll go into each of these separately. And then there's Docker Hub, which is the container registry, basically where all the images for different applications are maintained. So what's a Docker client server architecture, right? So Docker client is your typical command line interface, right? So you have CLI, which communicates with the Docker server. So you have to give command to Docker server if you want to build images or run containers, or you want to mount a volume, you want to set up a network, you have to send request to the Docker server, and it responds and sort of executes on your commands or whatever request you have placed. And we'll see those in the hands-on. So, but everything starts with something known as Docker file. Okay, Docker file is the most sort of, I would say, starting element if you were to use Docker. This is the most basic unit in order to use Dockers. Okay, so what is Docker file? Docker file is a simple text file with instructions to build a Docker image. So you can basically decide whether you want to build a very complex image, or you want to build a very simple image, Docker image, but it sort of generates from the Docker file. Now it can be easily created. It's a simple text file, so you can use touch or vi command, or simply create it in Windows also. So, but the file name has to be Docker file. Okay, because a Docker server would read that if there is any Docker file which is present, which can be used to build the image. Okay, so Docker file is used to understand what sort of dependencies or layers I need to build in order to run the application in container. Okay, so we, just to give you an example, if in this case from Ubuntu, right? So there are 2 types of images also, child images, base images, but generally you don't want to write or build an image from scratch, right? Because community and corporations have done so much around Dockers already that you can simply reuse some of those images, especially for standard applications, like if you want to install MySQL, if you want to install Redis or Node.js, there are standard Docker images available in the Docker Hub, which you can straightforward pull and start working. So, but child images are basically those, if you are using a base image and then making some changes on it, that's child image. But base images, when you are not using any existing Docker file or image, that's your base image, right? So like I said, Docker file is the starting element, or most initial sort of element in Docker. So from Docker file, you lead up to something known as Docker image. Okay, now Docker image is a blueprint essentially for your application, right? So in Docker image, you specify what do I need. Basically, it picks all the things required from Docker file, what it does, it just creates a sort of snapshot that what exactly is required in order to run this application. Now it would have what dependencies are there, libraries, right? So Docker image would ensure that it's a sort of package that can be now run inside a container. Okay. So from Docker image, you can run a container. So if you think what's the relation between Docker image and container, Docker image is a class, right? In if you know, I hope some of you are familiar with OOPS, right? Like object-oriented concepts. So Docker image essentially is your class, and Docker container is an instance of that. So you have all the dependencies and everything. Now container is a running instance of an image. Okay. Now, like I said, Docker image could be downloaded or uploaded to Docker Hub. So there are already lots of images which are there in the Docker Hub, and you could download those. You need to create credentials, Docker Hub credentials to download or upload the images. And from there, you can run individual containers easily. Now, some of you might be using Azure or AWS or Google Cloud, right? So each of these clouds also have their own container registries. So you don't need to push everything to, let's say, Docker Hub. If something is confidential and it has to be within the system, then you could use Elastic Container Registry, which is provided by AWS. And then you have Azure Container Registry, and you have Google Container Registry also. So you could have your specific Docker images, which could be pushed to these. Now, how does this work, right? So once you have, let's say, for example, you run Docker container run Redis, right? You are running a container which you need to sort of have Redis running on your system using Docker. So what it does, when you give this command, you give this through Docker CLI, like I said, right? That's the interface through which you can communicate with Docker. Then it sends this request to Docker server. And mind you, this is happening on local system. Now it would see if are there any local images which are already available. So it would look for Redis image if there are available locally. And if it doesn't found Redis image present local in the local system, it would send a request or pull the image from Docker Hub. Now, like I said, Docker Hub has already got multiple images with all the information. If you want to install SQL, Spark, Python, TensorFlow, there are pre-built images available on Docker Hub. So it would pull the Redis image and it would then execute or run inside a container. Okay. Now, what is the transition between Docker image to container, if we were to ask? So what image contains, right? So we understand image comes from a Docker file. Docker file would have certain commands. And when we create an image or build an image from Docker file, it has two mandatory things. Okay. One is file system snapshot, that in order to run, let's say I want to run two applications, Chrome and Python, what are the essential files or file system I need to have in order to run inside the container. So that's present. And then you have a startup command as well. So as soon as I run my container, it should start Chrome. Okay. So once the container starts from the image, it's an instance of running container. It will, first of all, it will have a dedicated set of resources, hardware resources, RAM, your hard drive, your CPU, and network. Okay, so a container would have its own network ports. It would have its own CPU usage, would have its own hard drive allocation and RAM. Okay, and inside using this, you can think of it as like enclosed OS, right? Within this OS, it would run these two applications. Okay, so this is how the transition happens from image to container, and all the dependencies, libraries would be picked from the Docker file, which was the starting point for a container. Okay, now you might think that container is running on my local host. How do I access it from outside, right? Which we are going to do today. So what happens is each of these containers that you run has its own network ports. So if you want to access it from outside, you have to map these ports of the running container to the local machine, right? So the host machine would have certain port, like let's say you want to map it to 8080. So there's something known as port mapping, right? We route the request which is coming to your local host, that as soon as any request comes, it would route it to your 8080 port of the network within the running container. So whichever application is running on or has the endpoints exposed on this port, it would send back the reply or the whatever is the needs to be sent to the through the local host. Okay, so you can access it within the container for a predefined port number. I hope Docker ecosystem is clear. We can move on to the Docker commands. Now, like I said, the starting point is Docker file, right? So Docker file has certain commands which are most useful. And the first one is from, right? This command allows you to, if it's not a base image, if it's a child image, it allows you to mention the base Docker image that you want to use as the platform to build on it. Okay, so like in our case, we saw from Ubuntu, right? So you want Ubuntu as your base image in order to run the application. Then you have run command, which sort of allows you to install different dependencies. So you can mention all the dependencies using run also. Then you have add. Add or working directly essentially helps you to copy any of the contents from your local machine to inside the container. So you can add any particular directory or all those. Environment essentially allows you to mention all the environment variables. For example, if you're using SQL or MySQL or Postgres, some of these credentials or you need to pass through env command. Okay. Next is expose and volume. Expose is like sort of for port mapping, like we saw 8080. So you expose certain ports of the running application within container, which can be accessed from outside. Then you have volume. Now, one thing to remember about container is if you are using a container and if you have not mounted or used volume, as soon as you kill the container, the data would be lost because it's a running instance. So it won't save data on its own. So you have to create volume or mount volume on a certain location that maps it to a local directory. Okay. So when you're using Dockers, it would save the data locally also, even though you close. Okay. And finally is CMD and entry point. Basically, what is the first command you want to run, which we saw, right? Run Chrome. That would, as soon as the container is up and running, what it should execute on. That's CMD. So let's say Docker info, right? If I go to terminal, right? So if I do Docker info, you can see it would give a lot of information like how many containers, how many are running, how many paused, stopped, right? How many images are present, right? Then there's volume. Okay. There's something known as Docker Swarm also, which could be a separate topic altogether. It just allows it's sort of mini version of Kubernetes. Those of you are familiar with Kubernetes, but it's a local implementation. So you can deploy multiple Docker containers and have a connected view across those. And you have OS type, okay, and total memory it's using. So there's a lot of information that you can get using Docker info command. Okay. Now, if you do Docker images, you would get all the Docker images that has been created. What's the size? What's the name? All those. Okay. Now, if you want to pull particular image from the Docker Hub, you can use command docker pull and just give the image name. So like docker pull nginx, right? So what it would do, it would try to look locally if nginx is present. If it is not, it would start downloading from the Docker Hub. Okay, like you can see, it creates and just I'll take just 1 minute to explain what are these numbers. These are temporary uh, image IDs, sort of, because what it happens, it pulls all the dependencies one by one, right? So for in order to have Nginx on the system, first it would create a temporary ID, it would complete the pull, then it would again assign it a new ID, and it would pull on top of this, right? So now this one would have both the items, and similarly this one would be pulled at the end. Okay, so that's how it sort of creates layer on layer, and you can think of it as an onion, right? So first item which is pulled, it's the most inside part of an onion, then you have next layer, then you have next, that you can run into the into form of Docker container. So you can pull image like this. So if I now see Docker images, you can see Nginx now available. Okay, so you have Docker build also. So if you have a Docker file, just in interest of time, I'll just rush through some of these commands, because we want to see the application also. So you can just create a Docker image from Docker file also, and we have to use command docker build, and dash t is to tag, right? So you want to give it a name, and dot is that there should be a Docker file in that directory. Okay. Okay, and there are some useful commands to get inside a running container. We use exec. Then there's volume if you want to create volume, which can be persisted. You have docker ps to see all the running containers or stopped containers. Then you have docker stop, right? So you can stop the container, kill the container, remove the container. You can remove the image also. So that's the Docker commands. Now coming to the containerizing an application, right? The steps, basically what we are going to cover today is, just a second. We build a machine learning model, simple one. Not the focus is not to build the very complex or most accurate model, but a simple model. Export the model object to use it for prediction. Then we create a Flask-based app, right? Flask is a web framework to deploy your app, and make use of Flasker to handle UI components. So those of you who are not familiar with Flasker, it's again used for to handle a UI component, right? So in case you use Flasker, you don't have to worry about HTML and CSS component of the UI. So might not be very relevant in all the cases of application deployment. For this purpose of demo, I thought this could be handy. So I've made use of Flasker. Now, once our application is developed for prediction using the trained model, we will wrap everything inside a Docker image. Okay. Now, once we have the Docker image, we will run the container out of the image and see if we can make the prediction and access it from outside. So we'll use the networking, we'll use the running instance of the Docker, and at the end, we'll stop or kill the container. Okay. So going to the core part. So if I do Jupyter Cook, I'll show you. So first, we have a simple Jupyter notebook to train the model, right? So we are importing NumPy and Pandas. There's a data set which is online sales. What it gives basically, yeah. So it has 3 columns. One is age, one is age of the user. Then you have new user, whether it's a repeat user or a new user. Then you have total pages visited. So if it's a website, how many pages they have visited and whether they have bought the product or not. Okay, that's the target class we have to predict. So if I do frequency count of the target class, you can see there are only 10,200 odd converted customers, whereas mainly almost 0.3 million customers haven't bought from the platform. Now, there are no missing values as such, and we don't have to worry about the data type also. And this bunch of just initial scanning of the data of the distribution, there is clear outlier like 123H. But it's fine. We don't have to worry about some of these outliers, because the idea is to not build the perfect model, but rather just see how we can use and wrap it up in a Docker container. Okay. So we build a quick model like age, new user, and total page visited becomes our input variable, and our converted becomes our target variable. So we train a simple logistic regression model. Now we do 70-30 split of the data, and we use stratify. Stratify because we saw a huge imbalance in the target class. So we will ensure that our train and test has a decent split of the target class. Okay, so we run this and you can see 3,000 converted customers are there in test and 7,000 are in the training. So let's train a logistic regression. Our accuracy is around 93%, which is fine. And we make the predictions. Now, if you were to just quickly scan the performance of the model, you can see for non-converted, precision is really good, 100%, but for converted, it falls dramatically. But for recall, it still holds good above 90, which is fine, right? So our main aim is to sort of figure out which are those converted customers, not worry about most of the non-converted. So we'll use this log reg as our model. Now, next step is to export this model, which can be then called for the predictions of new customers or unseen customers. So we use pickle. You can use joblib also to export the model. So here we are using pickle. So we name this model as pickle file logreg.pickle, and we write this to our current directory. Okay, and we will dump this model. Okay, so if I go back in the files, you can see logreg.pickle is now here seconds ago and 742 bytes of model. Now, before testing it inside the app, let's see if it's working fine on the test data. So we again load back the model. Here we are reading the model, okay, and now we try to predict using the model. So here you can see model.predict. We are passing 3 values, which is nothing but age of the user, your repeat versus new user, and your number of pages visited. And we are trying to predict, and it predicts 0. Okay. And if I were to change the age, let's say 45, it's a repeat user, new user, but it has viewed 30 pages, right? So model predicts, yes, it can be a potentially converted customer. Okay. So this was using a predict model for a single prediction. But let's say you have a new users list, right? And their data for last month. Now you want to predict on a set of customers. So in this case, you can pass the file also, which follows the format of the input data, and we can make predictions. Okay. So here you can see for each of the customers in test file, there's a prediction for the from the model. So that's our model training and export and testing everything. Then comes the Flask part. Okay. Flask part, we import Flask and request. And like I said, we'll use Flasker for our UI component. So here we are creating the Flask app name. We wrap it with Swagger. Okay. And we load our model. We load our model because we'll be using it for prediction. So here you can see we are assigning our model as model, and we are loading using pickle. Okay. Now we create 2 functions. One for predicting the single value. Second is predicting for the group file. So here you can see we are defining a function predict class, and predict is the endpoint. So when you're predicting, there's the endpoint is predict, and we'll use get methods because these are going to be individual values. Okay, so we'll use get method. In Flasker, you have to define parameters because it has to understand what input data is coming its way in order to predict. So here you can see we are defining parameters. That first is name, which is age. It will come as a query, and type is number. Okay, so quant, basically the data type would be numeric, and whether it's required or not. Okay, so these are defined, and here we are accepting those values using the request. Okay, so we do request arguments and get. So we use all the 3, and finally we use prediction model.predict. Okay, so here you can see our model will predict from all the inputs that we accept from the user. This is for the only single user prediction. But if you were to predict for a group of users or a test file, you have to use post, because we'll be posting the data, we'll be sending the data to the app, and it would return the value using the prediction. So here we use file and form data because it's not individual values. So we do request.files instead of arguments, because these are going to be set of values, and get file. Okay, so this is your Flask app. Then the final part is the Docker file. Okay, now Docker file is what is the blueprint for building the image and container. So this is the base file. We are using Anaconda, Continuum Anaconda as base image that give us all the dependencies to run Python, Flask and everything. Then we copy this content that we just saw, model, Docker file, your test data, requirement txt, everything, from the localhost system current directory to your Docker container. Okay, so in Docker container, it will create a folder name as user ml app, and under app it will put everything. Okay, now we have also exposed our port 5000. It would expose, or you can access the app on this port of the running container. We set the working directory as the app1 because all our files are there. And we also have set of different requirements which are mentioned in requirements txt, and we run in order to have those files installed inside the container. Okay, and finally the startup command, right? Once the container is up and running, what it should do, it should run this command python flask api.py, because Flask API py is what our application code is, right? It would execute and we can access the file application. So that's all. Once you have this, we can go to terminal and we can see if there are any current images. No, right? So now we can do docker build. Now, if you see, these are all the files that needs to be there, but inside Docker file, we have to build image using this Docker file. Okay, so we do tag. Okay, so this would be AV test, and we do dot. Now, since I have already downloaded, in interest of time, it would not take much time to create the Docker image, because we have otherwise it would download the base image first, then install all these dependencies. But for the base image, it already found it on the local system. Okay, so let it finish. Shouldn't take long because we are at the last step. So next step would be to sort of run the application. Here you can see 9 out of 9 finished. Now we have to do docker container run. We define the port number. Okay, so basically port mapping of local 5000 with container port. Okay, and we give the image name. What's the image name that we have created? It's AV test. Okay, so now it would run the container. So here you can see it's loaded. Now, in order to access the Swagger, you can use this HTTP localhost 5000 port number, and API docs is the endpoint to access. This is your application. Okay, this is your application running inside a Docker, not on localhost. So here you can see our Swagger API is up, and if now there are two parts, right? Get and post. Remember, for get, we have to submit individual values in order to use the model for prediction. So let's try it out. So let's give age of customer, let's say 50. New user, yes, it's a new user. Total pages of visited, just one page. So most probably it will predict 0. Here you can see model prediction is 0. Okay, so if we were to change, let's say 35, new user, no. Total pages visited 60. Here you would see model prediction 1. Okay, so we are using the model which we had trained. It's being used for prediction because we are sending the values which is received inside our running Docker container. Let's see post also. So if we were to predict for set of customers, let's use the test data and execute. So here you can see the model has predicted for set of customers. Okay. So going back to this, finally, I want to end with what are the benefits of using Docker, right? One is portability. You can easily take application dependencies and run it anywhere. There won't be any glitches or confusion about whether this application would run on certain platform or not, because Docker sort of removes away the layer of operating system dependencies, right? It's consistent and reliable. If you build application which is running on certain platform, it would run on any platform. Speed of deployment, you just saw, it's very easy. No, I won't call it very easy depending on the application or complexity, but building the Docker images and executing the containers, it's comparatively simpler than setting up the environment, installing the dependencies separately on local system or any other server. And efficiency and reduces operational overheads if you're building a large scale application as well. Cool. I think we are on time. I would be happy to answer if there are any questions.
So, sir, basically we have two questions in Q&A. So, one is, if there are multiple Docker images on a single computer, then should we have multiple files with the name Docker file?
So yeah, so if it depends in if you're in a working directory, right? Let's say you are in user app, so you could keep a separate Docker file there, and so each image needs to have a separate Docker file. Okay, you can't have two Docker files in the same folder, because your Docker file has to be named as Docker file only. So you have to change the location or a directory of that file in order to create the image.
So our second question is, sir, why do we need the Docker image? Can't we run container directly from the Docker file?
Unfortunately, no. Docker image is what sort of builds, or it's a blueprint, right? Text file won't lead to sort of virtualization, like I mentioned, right? Docker server, which or Docker daemon you can call it, it acts as a broker between your local hardware resources as well as your application. So unless you build the image which defines your resources required, the file structure required, the startup command, it won't be possible to run you're basically asking, if I don't define the class, can I use the instance, which is impossible. Thank you. It was great to be presenting this session. Thank you, everyone. Have a good day.